All right, hello there. If you've ever found yourself staring at a project management exam question while your head starts to spin, then you have landed in exactly the right place. Today we're going to get you sorted by tackling a classic, the critical chain problem. We'll break it down bit by bit so you can walk into that exam feeling totally confident. So picture this. You're handed a project plan. You've got a few tasks, you can see which one follows the other. It all looks pretty neat and tidy, doesn't it? A lovely little puzzle. I mean, what could possibly go wrong?
Ah, yes, reality bites. This is the classic spanner in the works. Suddenly, 2, maybe 3 tasks all need your star programmer or your only specialized machine. And this, right here, is where a simple-looking plan can fall to pieces. But it's also where critical chain thinking comes to the rescue. Right then, let's get our hands dirty with a proper exam-style question. We're gonna walk through this together, every single step, so by the end of it, you'll know exactly what to do. So don't you worry. So here's what we've got, a table with tasks from A through to F. You can see how long they're meant to take, what needs to finish before they can start, and the resource they need. Now pay attention to 2 things. First, those durations are safe, which is just exam speak for padded out with a bit of fluff. And second, have a look at that resource column. See how nearly everything needs R1? Well, we've only got one of them, and that is our pickle. Now, before we dive in, we need a toolkit. There are 3 golden rules to the critical chain method. Once you get these, the whole messy problem becomes, well, a piece of cake. Think of them as our secret weapons. Rule number 1 is all about being a bit ruthless. You see, it's just human nature to add a little safety cushion to an estimate, isn't it? Just in case. The problem is, that padding usually just gets wasted. So the critical chain method says, get rid of it. For an exam, this is dead simple. It almost always just means chopping the time in half. This gets us to how long the work should actually take. Rule number 2. Well, this one's just pure common sense, really. Resource leveling sounds all technical, but it's not. Think about it. If you go to a coffee shop with only one barista, you have to queue up, right? You can't have one person making 2 lattes at the exact same time. One of them has to wait. Simple as that. And rule number 3, buffers. Now, you're probably thinking, hold on a minute, didn't we just get rid of all the safety time? And yes, we did, but we're going to be much smarter about it. Instead of hiding little bits of padding in every single task, we're going to pool all that time we saved into one big, visible safety net for the entire project. It's like a shared shield we can use if things get tricky. Right, toolkit sorted, rules are clear. Let's apply them to our pickle and get this thing solved. Let's crack on. First job, part A. We take those safe times and we cut them right in half. So task A's 10 days becomes 5. Task B's 8 days becomes 4. C's 6 days becomes 3. You get the idea. Easy peasy. Now we have a realistic idea of how long everything should take. Okay, question time. Have a look at the plan. Task A finishes after 5 days. Once it's done, both task B and task C are ready to kick off. But can you spot the problem? They both need our one and only R1 resource. We've got ourselves a classic bottleneck. So what on earth do we do? We've got a choice to make, a real fork in the road. We have to make them queue up. Do we do B first and then C? Or do we let C go first, followed by B? The only way to know for sure which way is faster is to quickly sketch them both out and see which one gets us over the finish line quickest. And we have a winner. It turns out doing C before B gets the whole project done in 20 days. That's a whole 4 days quicker than the other way around. Let's just walk through it. A finishes on day 5, C nabs resource R1 and finishes on day 8. B then gets R1 and finishes on day 12. At the same time, E is doing its own thing. After that, D runs until day 17, and then F finishes it all off on day 20. And what we've just uncovered, that sequence, that's it. That's our critical chain. It's the longest path through the project, but, and this is key, it also accounts for those resource queues. So for us, it's A, then C, then B, then D, then F. All done in 20 aggressive days. Brilliant. We've got our super efficient, lean, mean project plan. But this is the real world, isn't it? And sometimes things go a bit pear-shaped. So now it's time for the really clever bit, building that safety net. So how do we figure out our main safety net, the project buffer? It's easy, honestly. You look only at the tasks on our new critical chain. Then you add up all the padding we trimmed off them at the start. So that's 5 days from A, 3 from C, 4 from B, 5 from D, and 3 from F, which comes to 20 days. And here's the trick. You just have it.
And there we have it. Half of 20 is 10. We have a 10-day project buffer. This is our shared piggy bank of time that sits at the very end of the project, ready to soak up any delays that might pop up along that critical path.
But hang on, what about delays on the other tasks, the ones that aren't on our main chain? Well, we need to protect our main path from them too. We can't have task E running late and holding everything up, can we? And for that, we use something called a feeding buffer.
The maths is exactly the same, dead easy. You just look at the path feeding into our main chain. In this case, it's just task E on its own. We trimmed 4 days of safety from it earlier. Half of that is 2 days. So we pop a little 2-day buffer just before task E's work meets the main chain. It acts like a little shock absorber.
And that's basically it. All the heavy lifting is done. Now all we have to do is put our answers together nice and clearly, just like you would on the exam paper. Bob's your uncle. Now the last part of the question usually throws a little curveball, like this. What happens if the project is running 4 days late? Well, this is exactly what our buffer is for. There's no drama, no panic. Those 4 days of delay just get soaked up by our 10-day safety net. So to answer the question, what percentage of the buffer have we used? Well, it's simple maths, isn't it? We've used 4 days out of a total of 10. That is 40%. We've still got 60% of our safety net left in the tank. We're still in good shape. Right then, let's put a bow on it and lay out the final answers. For part A, you've got your aggressive durations. For B, the critical chain is A, C, B, D, F, and it takes 20 days. For C, the project buffer is 10 days, and the feeding buffer is 2 days. For D, the total planned duration is the 20 days plus that 10-day buffer, making it 30 days. And for E, that 4-day delay eats up 40% of our buffer. Done. And there you have it. That's how you crack a critical chain question. It really just leaves you with one last thought to take away for your own work. Are your project plans genuinely safe, or are they just padded out with a bit of fluff? It's a really important question to ask. Thanks for joining me, and the very best of luck with your exams.